Hello all, welcome to another quick learning. Today we're going to be going over the NORMDIST and NORMSDIST function that you use with the normal distribution to figure out some questions you might want to ask about how likely it is that certain values are going to come up given that you have a normal distribution. So I set up this example, so we've got 6 die rolls that I'm simulating here. So I'm just using the RAM between 1 and 6 to simulate a 6-sided die. I'm doing that 6 times, and then I'm summing up the totals. All right, so this doesn't change. I'm just going to copy this and then paste values so it doesn't keep recalculating. And in this case, because I'm only doing 20 simulations of this, it's actually slightly lower than what you would theoretically calculate. Theoretically, it should be 21, as each die roll should be expected to roll 3.5 on any individual roll, and if you have 6 of them, that comes up to 21. But for some reason, this simulation rolled a little bit low, but we'll use that number anyways as the mean, and the standard deviation up here of 3.5. So basically, we want to answer a couple questions that I had. What's the chance of rolling 28 or higher? And what's the chance of rolling 28 specifically? So if you don't remember the normal distribution, this is it. So we've got the mean here at 0, and then 1 standard deviation. This is what that sigma means. To -1 to 1, we've got about 68% here. And then further out, you can see how it breaks down. And if you take the area under the curve from -infinity to infinity, this equals 1. So that's kind of what the NORMDIST does, is kind of takes the area under the curve depending on where you are. So if we want to do the chance of rolling 28 or higher, so we got about an average of 20, and we got a standard deviation of 3.5. So about 27 would be about 2 standard deviations above, so it's slightly higher than this. So it's going to take the area under the curve a little bit past the 2 standard deviations here in this example. So how do we do that? So you go equals. We're going to do NORMDIST. You can see here returns the normal cumulative distribution for the specified mean and standard deviation. So we're going to do that, and I'm actually going to hit this function button just to pull up this to make it a little easier to see what we're doing here. So we're putting in x, so x is the value we want to look up, which is the 28. So the mean is this cell right here, G22, which I've calculated the average. Standard deviation here is what we calculated standard deviation for those values. And then cumulative, we're going to say true, because we want what's the chance of rolling 28 or higher. So this is going to be what's the area under the curve up to that point. But what actually we want is 1 minus this value, so I'll calculate that. And then I'm going to go 1 minus that because we want what's past that under here. And since the total is 1, then what the extra left over on the right would be 1 minus that. So you can see it's about a 1% chance of rolling 28 or higher. And what's the chance of rolling 28 exactly? So we're going to do the same thing. We're going to do that NORMDIST. We're going to do x, 28. We're going to do mean here, that cell, standard deviation, that cell. And this time for the cumulative, we're going to put in false, because that's going to assume it's a discrete value, and it's going to look up what's the probability for that distinct value. And you can see it's about 0.8% given the average and standard deviation here. Now, like I said, this one's a little off what the theoretical should be, but it's just an example. All right, so we got that. Another similar function is the NORMSDIST. Now for this one, you put in a z-value. So first you need to know what a z-value is. So a z-value is, let's say for 28, so the z-value equals, we're going to do parentheses, how many standard deviations above or below the mean. So we're going to do 28 minus the average divided by standard deviations. So that's how many standard deviations 28 is above the mean. So it's 2.3. So our z-value for this problem is 2.3. So if we do NORMSDIST, and then we do, sorry, I wanted norms with an S dist, and then we're going to use that z-value that we just calculated, and you can see it's that, but we want the 1 minus that to get, and you can see we have the same number as here. So it gives you the same values, just whether you want to use a z-value or you want to put in the average and standard deviation. So those are two functions that you can use to figure out what the probabilities of different things based on a normal distribution. I hope you guys learned something. Thank you very much.